Hello again. In this video I'm going to show you how to plot quadratic functions. Sometimes quadratic functions look like a smile and sometimes they look like a frown. How do we know which is going to be which? Well, all quadratic functions are of this format. f of x is equal to ax squared plus bx plus c, where a, b and c are constants. So a, b and c are constant, and a must not be 0. The other two can be 0, but a can't be 0, because if a was 0 then 0 times x squared would be 0 and the function would just be bx plus c, which is a linear function. So the coefficient, that's the number before the x squared, the coefficient of x squared must be non-zero. So that is the coefficient Now, it is this coefficient of x squared which determines the shape of the quadratic function. If the coefficient of x squared is positive, so if a is bigger than 0, then our function looks like a smile. Whereas if our coefficient of x squared is less than 0, well then our function looks like a frown. And the way I look at it is, if a is positive, it's a smile, and if a is negative, it's a frown. So that's one way you can tell how your function is going to look. Now in this case, here's an exam question, and the function notation is slightly different. It says f takes x and maps it onto 10 minus x minus 2x squared. It's still a quadratic function because the highest power of x is 2. It's just that the order of the terms has been rearranged, so the x squared term is last. And you see that the coefficient of x squared is minus 2, which means that it's negative, so the shape of this function will look like a frown. Now we're asked to graph this in the domain, so this is our domain, in the domain from minus 3 to 3, where x is an element of reals. Now that just means that x can take any value along the real number line, and we only in practice need to sub in the whole number values, minus 3, minus 2, minus 1 and on up to 3. So let's do that first and foremost. So first of all we need to calculate f of minus 3, which basically means we substitute minus 3 into our function. Minus twice minus 3 squared. Now be very careful here, because this is where I notice a lot of students go wrong. When they are substituting minus 3 in for x, they do the following. Minus 3 is basically plus 3, because it's effectively minus 1 times minus 3, which is plus 3. Now, here's the mistake a lot of students make. They multiply minus 2 by minus 3 first to get 6, and then they square it. That's wrong. The only thing that's being squared here is the minus 3. So you do that first, and when you square minus 3, you get plus 9. We then multiply that by minus 2, and we get minus 18. So 10 plus 3 is 13. Take away 18, and we get minus 5. Now I want to write out my ordered pairs, so that means my input and my output. So when minus 3 is substituted in, I get minus 5. I'll do one more and then I might skip towards the end. So when we get f of minus 2, we sub minus 2 in for x, and that is 10 minus minus 2 minus twice minus 2 squared, and we have space over here, so let's write the rest of it out. So that is 10 minus minus 2 is plus 2. Now again we square the minus 2 first, giving me plus 4, then multiply it by minus 2, which is minus 8. 10 plus 2 is 12, minus 8 is 4. So when minus 2 is input, I get 4 as my output. Just to be totally clear, these are my ordered pairs, which I'm going to graph. We have minus 3 and 5, and we have minus 2 and 4. I need to do the same for minus 1, 0, 1, 2, and 3. So I'm going to skip through that, and you can rejoin me when I have those done. So I've calculated the input and output for all of the whole numbers between minus 3 and 3. And then I've labelled them all down at the bottom here, all of my ordered pairs. I've done this so that I can graph my function. Okay, so my y-axis I needed to go up as far as 10 and down as far as minus 11. My x-axis, my domain, goes from minus 3 to plus 3. Now notice that my x tick marks, I have made 2 squares each, whereas my tick marks on the y-axis I've made 1 each. It doesn't matter, as long as along the x-axis they're all the same size, and along the y-axis they're all the same size. So now I can plot my points. Okay, so I've drawn my graph. Remember the function is f of x equal to 10 minus x minus 2x squared. And we were asked a couple of questions. We were asked to estimate from the graph the maximum value of f of x. I think from my graph it is just a little bit up here, so I'm going to try and mark it off in yellow. Up there, it's just a little bit bigger than 10. So I'm going to say that the maximum value is I'm going to say 10.25. Let's say. What was the other question? Use your graph to estimate the values of x for which f of x is equal to 6. Now the values of x, so it uses the plural. So where f of x is equal to 6, now f of x is along the y-axis, so let's do this in green. Here's where f of x is 6. So we go across, let's do that better. So we go across from 6 until we meet our graph, and then we go down, and we'll find the values of x for which f of x is 6. So we'll go across and down, and this is one of the values here. I would say is 1.2. So values of x where f of x equal to 6 or x is equal to, I'll do the small one first, so that's minus 1.5 and x is equal to 1.2. So as you see from your graph, you can estimate values from your graph without having to substitute in and without having to use algebra. One more thing, let's say we were asked to estimate f of, let's say, 2.5. We would go to 2.5 along the x-axis now, because this is what we're substituting in. We would go down to our graph, and we would see that our value is 4. So we would say that's equal to 4 because we go down and across. So thanks for watching this video. I hope it has helped.